So when we think about Apollo, it was historic, sure, plant a flag, grab some rocks, come home, a waypoint.
Exactly, a visit.
But the next step, starting with Artemis, that's totally different. It's not about visiting anymore. It's about actually staying there. And this deep dive, well, it's all about that huge challenge, the logistics, the science needed to make the moon a permanent human home.
Yeah, and looking at the research, it's crystal clear. This isn't just some tricky engineering puzzle. We're talking life or death problems, truly. So our mission today is to really dig into those almost impossible challenges of living on the moon, and then look at the frankly ingenious science being cooked up to tackle them.
Okay, let's get into it, because the moon, it's just fundamentally hostile to us, isn't it? We've kind of flagged 4 massive hurdles. First off, the most immediate one, the vacuum. 0 atmosphere, like none.
Right, which means any place people live has to be perfectly sealed all the time against, well, nothingness, a complete void.
And that vacuum messes everything else up too, right? Temperature stability, gone.
Totally. Without air to sort of buffer things, the surface temperatures swing like crazy. You've got the 2-week lunar day, gets hotter than boiling, over 100 Celsius.
Ouch.
And then the 2-week night, it plunges down to, minus 173 C? It's like going from an oven to deep freeze every single month.
Okay, so air, temperature, immediate survival sorted maybe.
Okay.
But then there's the constant creeping danger, radiation.
Big one. Earth's magnetic field protects us here. On the moon, nothing. You're just blasted by solar radiation, cosmic rays.
Lethal stuff. So even if you seal the habitat and control the temperature, people inside are still getting zapped, leading to DNA damage, cancer risk. How fast do they need shielding?
Immediately. It has to be part of the basic design from day one, which leads into the solutions, but hang on, there's the 4th hurdle too.
Oh, right, the low gravity.
Yeah, just 1/6 of Earth's pull. And we now know that long-term, that messes humans up badly. Bones weaken, muscles waste away.
And didn't studies show effects on eyesight too?
That's right, adverse effects on vision. So it's a whole body problem over time.
Wow. Okay, so fight the vacuum, the temperature extremes, deadly radiation, and physical decay from low gravity all at once. The solutions must be pretty clever.
They really are. It's like a layered defense system they're planning. The first layer is the habitat structure itself. That's where regolith shielding comes in.
Regolith.
Yeah.
That's the lunar soil, the dust, right?
Exactly. That fine gray powder everywhere. The plan is to basically use it like construction material, 3D printing massive domes or structures using the regolith. Its density provides mass, and you pilot thick estimates suggest maybe 5-6 feet deep to block that radiation we talked about.
5 or 6 feet of packed dust.
Huh.
Just to shield against radiation. That shows the scale of this.
It does. Massive construction, but using local material is key.
And speaking of local resources, that brings us to water, doesn't it? That discovery of water ice near the South Pole in those dark craters. That sounds like a game changer, this whole ISRU idea.
Oh, absolutely huge. In situ resource utilization, using what's already there. And the water isn't just for drinking, though that's vital. You split the water molecules H2O into hydrogen and oxygen.
Right, electrolysis.
And boom, you get breathable oxygen for the habitats. And crucially, you get hydrogen and oxygen, the components for rocket fuel, bipropellant fuel.
So the moon could actually refuel rockets, become a sort of pit stop.
Precisely. A self-sustaining outpost, maybe even a transportation hub. Instead of constantly needing expensive supplies shipped from Earth, it changes the economics entirely.
Okay, 3rd layer of defense. Going underground seems obvious with all that radiation, right? You mentioned lava tubes.
Yes. These huge ancient caves formed by volcanic flows billions of years ago. They're potentially enormous.
Natural shelters.
Exactly. They offer instant protection from micrometeoroids hitting the surface. But the big win is radiation shielding. A thick layer of solid rock overhead is way, way better than even several feet of piled up regolith.
So these lava tubes could be like ready-made sites for the main base camps. Protected, stable.
Potentially, yes. Large, naturally shielded environments. It's a very active area of research and exploration planning.
And this isn't just sci-fi brainstorming anymore. NASA's Artemis program. Its whole goal is a permanent, sustainable base camp on the moon, planned for the end of this decade, right?
That's the plan. The commitment seems solid. We're moving from theory towards actually doing it.
So, boiling it down, living on the moon presents these almost impossible-sounding challenges.
Definitely.
Yet the solutions, the really viable ones, seem to come from using the moon itself. The dust, the ice, the caves.
That's the core insight, I think. Leveraging the lunar environment, turning its resources from challenges into solutions. It's difficult, monumental effort required, but the science suggests it's, well, doable.
Okay, so we've established humans can likely live there with incredible effort. But we started by talking about that 16th gravity and its serious long-term health impacts the weakened bones, muscle loss. So here's something for you, the listener, to think about. If we establish a permanent colony and people start having children there, what kind of completely new evolutionary pressures might that constant low-gravity environment put on the first generation actually born on the moon? Something we haven't really considered before.